Hi, I'm Chris from Glad Science, and I'm glad to see you. The mole is one of the most important concepts in all of chemistry, with a key role in the mathematics behind all chemical calculations. Avogadro's number describes how many atoms or particles are in a single mole of any given element. (6.02 times 10 to the 23rd power). This is Avogadro's number. Moles and grams can be related using atomic masses provided by the periodic table. The atomic mass provided in AMU for each element in the periodic table is the same as its molar mass. For example, if one carbon-12 atom weighs 12 AMU, then 1 mole of carbon-12 atoms would weigh 12 grams. Moles can simply be calculated using the equation moles equals grams divided by molar mass. So I'm going to briefly introduce the ideal gas equation, which can be featured in a future video, but you'll just need to know how to calculate the number of gas moles based on other information provided such as pressure, volume, and temperature. PV equals nRT. This is the ideal gas equation. Pressure times volume equals moles times the universal gas constant times temperature. So in a very basic situation without doing any conversions, P is pressure in ATM, V is the volume in liters, N is the amount of moles of substance, R is the universal gas constant, which is 0.0826 liters times ATM over moles times Kelvin, and T is temperature in kelvins, not degrees, not Celsius, but kelvins. Kelvin is actually another unit of temperature, which is just 273.15 plus degrees Celsius. You should also know that at STP, or standard temperature and pressure, that the pressure is equal to 1 atm and the temperature is equal to 273 degrees Kelvin. It should also be common knowledge that 1 mole of gas at STP is 22.4 liters per mole. So when a problem states that the conditions are at STP, you should always know that is 1 atm, 273 degrees Kelvin, and in order to convert the amount of moles of gas into liters, you just multiply it by 22.4 liters per mole. On the AP and SAT exams, you will need to know how to calculate percent composition or percent by mass of each element that makes up a compound. Let's take calcium nitrate for an example. Okay, so in calcium nitrate, you have 1 calcium atom, 2 nitrogen atoms, and 6 oxygen atoms. So all you need to do is take the molar mass of each element and multiply it by the amount of atoms in a compound. For example, calcium, you multiply 40.08 grams per mole times 1 mole gives you 40.08 grams. Likewise, for nitrogen, you do 14.01 times 2, because there are 2 atoms in one compound, equal to 28.02. So you do this for all the elements present in the compound. So the sum gives you the entire molar mass of the entire compound. Okay, so your final step is to take your entire mass of one element and to divide it by the entire molar mass of the entire compound. For example, we only had 40.08 grams of calcium divided by 164.1 grams per mole of calcium nitrate. So that gives us 24.42%. You do the same thing for the other elements, and then when you add up all of the percentages, you find that it is equal to 100%, if not very close to 100%. In this case, we have 99.99%. So that gives you the percent composition of one compound. Furthermore, the empirical formula represents the simplest ratio of one element to another in a compound. Likewise, the molecular formula represents the actual formula for a substance. Okay, so let's say a problem gives you a substance that is 56.5% carbon by mass, 7.11% hydrogen by mass, and 36.4% phosphorus by mass. So all you need to do is assume that the substance is 100 grams. So in that substance, you would have 56.5 grams of carbon. So you would multiply that by 1 mole of carbon over 12.01 grams of carbon. And that would give you about 4.71 moles of carbon. Likewise, you do the same for hydrogen and phosphorus, and you discover that there are 7.04 moles of hydrogen and 1.18 moles of phosphorus. So at this point, all you need to do is, out of these three numbers, find out which one is the smallest. Obviously, phosphorus has the least amount of moles, 1.18. So now what we're going to do is divide each of these values by 1.18. Okay, so you can see that on the top part, I divided each amount of moles by 1.18. So we discovered that the ratio of carbon to phosphorus is 4, hydrogen to phosphorus is 6, and phosphorus to phosphorus is obviously 1. So your empirical formula is carbon 4, hydrogen 6, phosphorus 1. So for example, for the molecular formula, let's assume that a compound is 174.14 grams per mole. All you need to do to discover the molecular formula, divide the compound's molar mass by the molar mass of the empirical formula. So I already did the math, and the mass of the empirical formula is 85.07 grams per mole. So 170.14 divided by 85.07 gives you approximately 2. So all you need to do is multiply the subscripts of the empirical formula by 2, and you discover that the molecular formula is C8H12P2. So thank you for checking us out, and I'm always glad to be of help.